In this lecture, we're going to study the polymerization of alkenes. Now, before moving to the polymerization of alkene, we must first understand what is meant by the term polymer. Now, a polymer is it's a very large molecule, and it's also the other name for a polymer is a macro molecule. Now, it's a very large molecule and it's in the form of chains, and it's a large molecule formed when many small monomers. Now, what is meant by the term monomer is it's a small molecule or a small unit. So it's formed when many small monomers they join together. So basically, a monomer is a small single unit. It's a small molecule. A polymer is when many different monomers they join together and they form a very large chain. So the way this is going to happen is, if I give you an example, if I have a small molecule, let's say this box represents a small molecule, and when you talk about polymerization of alkenes, then these small molecules are alkenes. These units, these building blocks of polymers, they are alkenes. They are simple alkenes which have double bonds in between. So I've drawn a few small single units, and what's going to happen is that they are going to all end up joining together. So they start bonding with each other, and when they bond to each other, a chain is formed, and generally this chain is very long. It could be as long as a few hundred monomers, or it could be as large as a few 100,000 monomers. So there could be a chain with only a few hundred molecules that join together. It could be a few 100,000 molecules that end up joining together. So there's a wide variety of polymers, and each polymer, when polymerization happens, you get a variety of different chains, each having a different length. So under very high pressures and high temperatures, we have alkenes which will be our monomers. They would be our units which are going to end up joining together. So I'm going to start off with a simple alkene, the simplest alkene, which is ethene. So I'm going to start drawing ethene molecules. There would be eth means there are two carbon atoms. Ene means there's going to be a carbon double bond carbon. So I'm drawing the simplest possible alkene, the smallest possible alkene. So this is one ethene molecule. This would be another ethene molecule. Now we have all these ethene molecules. And let me draw 5 of these. So here's the 5th one. And in one polymer which is made from ethene, you can have thousands of different ethenes joining together. So I'm just drawing 5 of them. Now what's going to happen when you put ethene under high pressure, all these alkene molecules, so under high pressure, and high temperatures, so under high pressure and high temperature, what happens is that the double bond that is joining the alkene molecules, that breaks. It doesn't break. It basically gets converted into a single bond. So I'm going to rub off these double bonds. So the double bonds are now gone, and instead these double bonds get broken up into single bonds. So you have single bonds instead of these double bonds. Now when this happens, when this particular thing happens, carbon is no longer, if you look at this carbon atom, it no longer is making 4 bonds. It's supposed to make 4 bonds. It's making 3 bonds. Actually, if you look at all the carbon atoms, once the double bond is broken down into a single bond, all the carbon atoms have 1 bond missing. So what they do is they start bonding with each other to complete the 4th bond. Now, if you look at this carbon atom over here, this carbon atom over here is now making 4 bonds. This carbon atom over here is also now making a total of 4 bonds. The same thing happens with the carbon atoms over here. This is making 3 bonds. This is also making a total of 3 bonds. They would end up bonding with each other, and they're going to make their 4th bond with each other. Same thing happens over here. These 2 carbon atoms are making 3 bonds each. They end up bonding with each other. These 2 carbon atoms also are making 3 bonds right now, 1, 2, and 3, and this is also making 1, 2, and 3. So the 4th bond is formed between them, and this chain keeps on continuing. It's going to be a very long chain, and all the monomers, all the small ethene molecules, they end up joining together, and this is what we call a polymer. And specifically, since it's made from ethene, it would be called a polyethene. That is how you're going to name polymers. It's going to be the monomer. You're going to write down the monomer, and once those monomers have joined together, our monomer in this case was ethene. So once those monomers have joined together, you're going to call it poly / the name of the monomer. So it's going to be called polyethene. And you have to be careful drawing a few more things. For example, you must always show these bonds, which means these are called continuation. These are called continuation bonds. And 1 bond over here. So whenever you draw a polymer, you must show these continuation bonds, which indicate that you have just drawn a portion of the molecule and you haven't drawn the full version of the molecule, because the full version of the molecule might contain 2,000 or 10,000 or 100,000 monomers which are joining together. So you can't draw all of them. So you've just drawn a portion of it. So there's a simpler way of representing this polymer, which is that instead of drawing 3 or 4 or 5 repeat units, what you do is you simply look for the smallest repeat unit, which in this case is probably going to be this one. So this thing is being repeated over and over again. So you look at that unit, you write down that unit, and so this monomer residue is being repeated over and over again. So you draw the continuation bonds, and then you put square brackets around it, meaning that this structure is being repeated n times, which could be thousands of times or hundreds of thousands of times. So n is the number of times this structure repeats. So that is how you draw a polymer of ethene. We will now move on to the polymerization of propene, which is going to be slightly more complicated. Let me first draw the molecule of propene, which is going to have 3 carbon atoms, and there's going to be a double bond between 2 of them, since it's an alkene. And I'm going to draw all the hydrogen atoms. This carbon atom is going to have 2 hydrogen atoms. This is making a total of 3 bonds, so it needs a 4th bond, and this needs 3 more bonds. So that is one propene molecule. And let's draw another one, and you're going to have it's going to have two hydrogens over here, one over here, and this carbon needs to make a total of 4 bonds, so it needs 3 hydrogens. And let's draw another propene. Now all these propenes are going to end up joining together. This has 1 hydrogen and this is going to have 3 hydrogens. So those are your 3 propene molecules. Now they will end up joining together, which means that double bonds are going to get converted to single bonds. So all these double bonds, I'm going to rub off those double bonds, and under high pressures and high temperatures, these double bonds, they will break up and they will be converted to single bonds. Instead, I'm going to draw single bonds in their place. So these 2 carbon atoms form single bonds instead of the double bond which they were previously making. And now if you look, this carbon atom is now making only 3 bonds. Similarly, this carbon atom over here is making 3 bonds. Now to complete the 4th bond, this carbon atom would go and it would try and bond with this carbon atom. Similarly, this carbon atom over here is making 3 bonds. It needs to make a 4th bond. This carbon atom over here is making 3 bonds. It needs to make a 4th bond. So this carbon atom would go and it would try and make a bond with this carbon atom. Similarly, you have this carbon atom over here at the end. It's also making 3 bonds. So it's going to go and try and bond with some other propene molecule. And this carbon atom on the left hand side is also making 3 bonds, 1, 2 and 3. So it's going to try and bond with another propene molecule. So this is how they're going to bond up. They're going to join together. But how do you draw them? That's a problem. If you try to draw it like this, it doesn't look very neat. And especially the bonds are not like this. I need to rotate this particular molecule over here. And I need to somehow bring this carbon atom close to this carbon atom so that I can draw a bond. So it's going to be a very complicated shape. An easier method of drawing a molecule of propene, which would be called polypropene, as a polymer propene, is that you redraw a propene molecule. Propene that I drew previously looked something like this. And this had 3 hydrogen atom. Now, when I talk about redrawing the molecule, what I mean is that remember one thing, that bending and rotation does not change the molecule. So bending and rotation does not change the molecule. Rotation does not change. It doesn't change anything. It does not change the molecule. If you look carefully, I had drawn hydrogen on the right hand side. What I could do is that I could rub the hydrogen from the right hand side and I could draw it somewhere else. Instead of drawing on the right side, I can draw it below, downwards. Similarly, I had drawn this entire CH3, this part, on the left hand side. What I could do is I could, instead of drawing it on the left hand side, I can draw it below it. So if I try to bend this, if I try to bend it and position it somewhere else, that won't change the shape of the molecule. So I can do that. So what I'll do is that let me redraw this so that we have a clear example in front of us. So if I redraw this, then I'll have 2 carbon double bonds. Let's start from this side. and it's going to be a hydrogen over here, and then you have a hydrogen on top. And instead of drawing, let's focus on these two carbon atoms. They're the same carbon atoms I'm trying to draw. So instead of drawing this CH3 part on the left hand side, I can decide to draw it underneath this. So if you look carefully, the only thing that I have done differently is that I've drawn this CH3 part. Instead of drawing it on the left hand side of this carbon atom, I've drawn it below the carbon atom. And similarly, we decided to bend this hydrogen atom and bring it below. So what I'm trying to do is I'm trying to redraw the propene molecule in a way that becomes easier for me to make a molecular polypropene. And the rule is, the 3 basic rules that you need to remember is, the rule is that you should only have the carbon, double bond carbon on the horizontal axis. And the second rule is that all the other bonds must be drawn either upwards or downwards. There should be nothing to the right and left of these carbon double bond carbons. So all the other bonds must be drawn upwards or downwards. So you should have anything to the right or to the left of these double bonds. So let's see how easily we can form a polymer now. If I've redrawn a propene, so a propene would look like this. It's going to have 3 carbon atoms. Instead of drawing the 3rd carbon atom to the left, I'm drawing it below. And let's complete the hydrogen atom. There shouldn't be anything to the right and to the left of these double bonds. So this is going to have 2 hydrogen atoms, so I'm going to draw 2 hydrogen atoms. This is going to have 1 more bond with a hydrogen atom. This is going to have 3 hydrogen atoms. So I've drawn a bent propene molecule, and I will draw. Let's say I'll draw 3 propene molecules just to show how a chain would be formed. So this again is going to be drawn in exactly the same way. And I'll have another one. And the CH3 is drawn downwards now. Now if you look, all these propene molecules have nothing to the right and to the left of the double bond. And the remaining is now exactly the same that we did with the ethene. You rub off the double bonds and you convert that into a single bond. So all these double bonds under high pressure and high temperature, they're going to break and they will be converted to single bonds. So these are now forming single bonds. And if you look at the carbon atoms, each of the carbon atoms, this carbon atom over here is now making a total of 3 bonds. This carbon atom over here is now making a total of 3 bonds. So they're going to make a 4th bond, which is going to be joining them. So they're going to make up a 4th bond. Similarly, this carbon atom over here and this carbon atom over here is making, they're both making 3 bonds. So they're going to join up and they're going to form a link. They're going to link up and they're going to make their 4th bond. And in a similar way, this would represent a continuation bond. This carbon atom was making 3 bonds. So it's going to make a 4th bond with another propene on the right hand side. And this one is also making a total of 3 bonds. It's going to make another bond to the left side, and these are continuation bonds. And another way of representing a molecular polypropene now is, let me write down that this is now a molecule of polypropene, or a partially drawn structure of a propene, because it can contain many thousands of propene molecules linked together. So this is a polypropene, and the other way of drawing a polypropene is that you draw one repeat unit, which in our case is going to be it's going to be this thing is being, now this structure is being repeated over and over again. So you just draw this structure, which is you have these two carbon atoms, there's a hydrogen atom on top, and there's a hydrogen atom over here, and the CH3 is downwards. And if you look, there would be a continuation bond. This is the structure that is being repeated over and over again. And you're going to draw square brackets, meaning this structure is the one that is being repeated over and over again, and you write n to it, where n is the number of repeat units. So this is the other way of drawing this structure and writing down this structure. It's a compressed version. So that's how we're going to draw the molecular propene. And if you let's revisit and revise what we just did, the first thing that you're going to do is that it would be very hard. If you look at the structure over here, it would be very hard to draw the structure of polypropene if you have all the three carbon atoms in a straight chain. Instead, what you do is you just keep the double bond over here. You just keep the double bond on the axis, and you don't draw anything to the right or to the left. Anything that is coming to the left would be drawn downwards. So that's what we did over here. We drew the propene in a different way. Instead of drawing the three carbon atoms in a line, we drew the double bonds we kept the double bonds on the horizontal axis, and we drew the third carbon atom downwards. And we then completed the molecule by drawing the hydrogen atoms, and then we drew these repeat units, propene molecules, and the double bond broke and they started attaching and linking themselves up together, and that is how you form a structure of polypropene. And this is the compressed version. You just draw the simplest repeat unit that's being repeated over and over again, and you draw square brackets around it, and you write n, where n is the number of times this structure is going to repeat.